Welcome everyone. This is the first series of talks on the day. This is room 1.10. As you know, this particular room will host all of the English-based tracks that we have, right? And just a few reminders. We are going to be starting now at 25. The talk will take 30 minutes, and we'll have some space for questions at the end, around 5 to 10 minutes. So please, if you have questions, please wait until the end to ask Ben, our host here today. Right, so I'm here. I'm going to present our wonderful Ben, Lomax, here today. He is... Cheer for him, cheer for him. He's got a fun clap, I didn't know that. All right, so Ben is a senior software developer at Kraken Technologies, and he's based in North Wales, is that right?
Correct.
Nice, thank you for coming all the way down here to the Canary Islands, you're very welcome. And your hobbies, if I may talk about them, are travel, keyboards, which is fun, because we were trying to set up the the clicker beforehand, and it sprung some keyword configuration thing that we didn't manage to get right, so that's how it goes for it. And fighting climate crisis and chatting tech with fellow humans. I think you're in the right place for that. So yeah, Ben is going to talk to us about the art of the pull request. Please give a warm welcome to Ben Lomax.
Thank you everyone for being here. So today's talk is the art of the pull request. As we've just covered, my name is Ben Lomax. I'm a senior software developer at Kraken Technologies. We are mainly a renewable energy company trying to help drive forward the green energy revolution. We actually have a booth here at the conference, so come over for a chat, or if you want a chance to win yourself one of these cute octopus plushies. So, before explaining how you can craft better quality pull requests, or PRs, I want to spend a bit of time explaining why it's worth your time to practice structuring your PRs better. To start with, why even bother doing PRs at all? Why not just let everybody on your team push code straight to production? It would certainly be faster. I think it's fair to say there are a number of pretty clear benefits to this. First of all, code quality. PRs are good mechanisms for finding bugs before they hit production, for making good architectural decisions about the code, for keeping the code quality generally high, and if we're being a bit more cynical, it's also good to help stop malicious code from getting into your code base. Now, secondly, PRs make for excellent learning and teaching opportunities for a whole number of reasons. The problems are real, with nuance and complexity. You hopefully care enough about them to actually see it through. You can discuss solutions with multiple people at the same time, and you have a written record of the decisions and explanations to refer to later on. So, flipping the question around, what are the costs to developers being required to do PRs? Well, reviewing PRs takes time, and it takes mental energy. Both of these are limited daily resources, shared with all of the other tasks that developers are expected to do. If PRs are slow to be reviewed, they can also block work from getting deployed and can be incredibly frustrating, which can in turn kill your entire team's morale. So, why improve PR structure? Since getting PRs reviewed is something that the majority of developers working in teams do on a weekly or even a daily basis, it makes sense to try and maximize the benefits and to minimize the downsides. So to paraphrase what I've said so far, it would be great if PRs could get reviewed sooner, be faster and easier to review, make it easier to spot bugs, either unintentional or malicious, make it easier to spot bad architectural decisions, keep code quality generally high, and offer better learning and teaching opportunities. Now, I'm going to argue that you can get all of these benefits from just improving the structure of your PR, completely independently from the actual changes that you're making or even the language that you're using. Now, the rest of the talk will look at tips on how to do exactly this. Oh, and I'll mention now that there's an underlying approach to each of these tips, which I'll reveal at the end. So see if you can figure out what that is before I reveal it. Tip number 1, keep PRs small, because large PRs discourage reviews. Now, if during part of my working day, I decide that I have a bit of spare time to go and review some of my team's PRs, and I come across something that looks like this, there is a very high chance that I will do one of 3 things. First of all, just not do it. I don't have an hour to spare right now to do this. Number 2, I might start the review, but burn out or run out of time halfway through it and just not finish it. Now, I'm both burnt out and the PR didn't even get reviewed. That was a massive waste of my time and mental energy. Even worse than this is that I might start the review, burn out halfway through, and still approve the PR anyway. I've not actually finished checking the code properly, but I just don't want to be looking at this PR anymore. Now, none of these are good options. At best, you force a reviewer to use up a big chunk of their time and mental energy, which are their finite resources for the day. At worst, this leads to code not actually being checked and critical bugs getting merged. Now, keeping PRs small is the absolute best way to get them reviewed sooner, faster, and more thoroughly, as reviewers won't be scared away or burnt out by them. Okay, so how do you keep PR small? First thing, do only one thing. So keep each PR focused on solving just one problem. Don't try to do multiple features or tickets in the same PR. If you find an unrelated bug that you want to fix straight away, that's fine, but try and pull it out into its own PR. Now, this also reduces the amount of time that PRs stay open. If you do features A and B in the same PR, any issues with B will block A, even if you've coded A perfectly the first time round. Number 2, pull out any initial refactoring. So sometimes in order to cleanly change functionality, the existing shape of the code needs to be rearranged. Now this one depends a little bit on just how much initial refactoring you need to do. Sometimes these are small refactors, and you can just do them in a separate commit. Examples of when it can be worth creating a whole new PR for initial refactors might be when the current code is in such a bad shape that you have problems understanding understanding the logic before even starting the code. Another example might be if you want to add a layer of abstraction to the code, which your functional changes will then later use. Number 3, split your dependency diagram. Now, this is where the magic happens. Sometimes you have a large PR with lots of interconnected code that doesn't require any initial refactoring. The key to breaking up these PRs is to find the logical components of the change and figure out the dependency diagram. So for example, let's say that you want to allow people to control a heat pump in their own house from your website. In order to do this, you'll need to handle a number of different things. Building a UI to give customers a way to actually be able to control the heat pump. Sending the desired temperature to the third-party heat pump API. It would also be useful to know the temperature, the current temperature, so you'll need to get that from the API. You need some sort of authorization checks to make sure that users can only control their own heat pumps. And you'll need some concept of heat pumps and users in your system. This can often be things like database models. The business has also told you that we need to send out an email to the user if we can't reach the API for them for a particular amount of time. And finally, we don't want the API to rate limit us, so caching our calls is probably a good idea. Now, for tech or business reasons, all of these are required for the MVP. But this is likely too big for one single PR. That will lead you back to that huge PR diff that I showed you earlier. Now, to break this up, you just need to figure out the pieces that are dependent on each other. So looking at this, you need the user and heat pump database models to be able to do the auth checks that combine the two. You need the user models and the API code to work to be able to send the warning email. You need the API code to be able to cache those calls, and arguably the UI can be done independently and then plugged in later, but maybe you want to have the backend in place so it can be tested whilst you get on with the UI. You certainly can't finish the UI without the auth checks in place, preferably with the caching working as well. So don't worry if you've not caught all of that. Basically, this leads to a dependency diagram that looks something like this. Now, you might disagree with my diagram, and that's completely fine. There are different versions of a dependency diagram, which are all valid. The important thing is that you create some version of this, even if that's just in your head. Now, looking at this diagram, it's clear that you can start building the database models by themselves without needing to think about anything else. Same logic for sending and getting the temperature from the API. So right there, you can see very clearly that you have 3 PRs that you can start that are independent, and you can keep them small. Obviously, from here, you can also tell once the database models are merged, you can do the auth checks. Once the models and the sending temperature to the API, you can do the warning email, et cetera, et cetera. Now, all of this is context dependent as to what makes the most sense. If the API calls are super simple, then maybe all of the API work, the sending and the getting temperature, can be done in one PR. Maybe it makes sense to do the caching in the same PR as the API work. Since nothing else depends on it, maybe that sending the warning email can just get pushed out of scope. Now, being able to split out the components and figure out the dependency diagram means that you can consciously decide how to best break up large features into small PRs that are still useful. Understanding how the components relate to each other will also force you to think more deeply about the code, making more deliberate architectural decisions and raising issues sooner. All right, now I've got a couple of rules of thumbs. It's worth noting that all of the ones that I'll show you in the presentation are very much my own opinion. My recommendation is that PRs shouldn't be more than a few hundred lines of code, with the possible exception if you've moved some files around, in which case that might blow out very quickly. If you ever feel like apologizing for a PR being too big, you already know that it's too big. Just break it up. All right, tip number 2. Create atomic commits. You should only express one thought with each commit. So we've now broken our feature up into multiple chunks of sensible size. Let's look at how to structure the commits for one of those chunks. The thinking here is going to be very similar to the last section, but more tightly focused. Now, you've decided the heat pump API work is simple enough that you can do all of it in one PR. Stepping through the same process before, you figure out the required steps. You need to craft the correct get and post syntax. You need to be able to parse the response from both of those calls. You need to be able to create an initial connection using your organization's secret key. And you need to use the correct account auth token so you can control the correct heat pump for an account and stop people being able to heat other people's homes, or cool them in this country. Finally, you need to add tests to all of these things. Now, while the total amount of code could be suitable for a single PR, doing all of this in one commit requires the reviewer to keep in mind multiple different trains of thought, checking that each one is correct, tested, and interacts with each other and existing code. Doing this mental juggling is very difficult. Even if the reviewer is able to do all of this, they are likely only able to do this at a superficial level. Checking a single change is much easier, and the reviewer can keep all aspects of that change in mind at the same time. Now, in turn, this means that they are able to consider each change more deeply, which can include how it interacts with existing code, if the solution is well architected, not just that it works, and finding more subtle bugs in your code. They are also more likely to take the time to explain alternative solutions or to question your approach, which are excellent learning and teaching opportunities for you. So in this case, the dependency diagram might look something like this. You need all of the auth stuff to be able to make the calls, and you need to make the calls to be able to parse the responses. Now, you'll notice that I've dropped the test component in here, because ideally each commit should have tests in it for the functionality that it adds or changes. Now, some of these might seem like useless steps by themselves. Getting an account's auth key isn't useful without actually using it. But there's also no harm in having a fully tested function that gets the correct key. Doing so creates a piece of functionality that can be neatly used in later commits when we're putting together the API calls. Now, breaking up a PR into this kind of granularity of commits can mean that you create many more commits per PR than you normally do. That is completely fine. The number of commits per PR is very rarely the problem. It is almost always the size of the commits which are problematic. A one-line change that fixes a typo takes 2 seconds to check, be happy with, and then it stops it from visually polluting the next more complicated commit. So the rule of thumb is if your commit message mentions that you are doing X and Y in this commit, each of those should probably have their own commit. Tip number 3, refactoring versus functional commits. Just don't mix them together. Now, this is partly because reviewing, refactoring, and functional changes requires slightly different skills from a reviewer. Refactoring changes don't change the behavior of the code. For these, a reviewer just needs to make sure that the code at the start and at the end of the commit do the same thing. There's arguably no need to really understand the business logic of the code, since you shouldn't be changing it. And this would be things like renaming variables, pulling code out into separate functions, and moving files to different locations. Ideally, you should also already have tests that check all of this functionality, so that when you change it, you're comfortable that you've not broken anything important. Now, functional changes, on the other hand, do change the behavior of the code. These are usually the reason that you're doing any of this work in the first place. And they are also the ones that require more from a reviewer. The reviewer should understand what the code is doing and why, along with any relevant context around the change. And they also need to make sure that the tests that you've written actually test the change. In short, you want to make the functional commits as clean as possible, so that the reviewer has the best possible chance to catch any errors and to give insightful comments and suggestions. Now here's another toy example. Imagine that you're partway through a commit that spans a few dozen lines, a few dozen lines and several files. Suddenly, you run into this. So we used to do things with foo, but now we're doing handle foo instead, and then we're also doing something with the outcome of this other function. Wait, what? Well, it turns out that a few files ago, this change was made. Here, the author has added some new functionality, and while here has also renamed the function to be more explicit. Both of these changes are useful, and they will help to raise the quality of the code. However, if you spend the majority of your valuable mental energy as a reviewer making sure that the new functionality is correct, i.e. that adding an error if foo.x equals 2, then it might have slipped your attention or your memory that the author has also improved the name. It's just not as an important a change. But if this trips you up later in the commit, it might be enough to force you to lose your train of thought. Need to find where the name was first changed, and then have to re-immerse yourself in the functional changes again. Now, obviously, this is a small toy example, and simple enough that all of you might be able to easily handle this. But for larger, much more complex commits, this can be a pretty big hit. So splitting up the refactoring and functional changes would look something like this. First, you have a tiny commit which renames the function to be more explicit. This takes exactly 3 seconds for a reviewer to look at, be happy, and move on. Next, the functional change. When in the later section, it's immediately obvious that we're running the same function, handle foo, but we're now getting the return values from it and doing something with them. Hopefully, most of you agree that this is easier to read. Now, one final thought is that I would recommend putting refactoring changes before functional ones. Refactoring code is usually done to improve it. So why not improve the code first and then add the complex functional changes to the improved code? Tip number 4, give enough context. Context is important, but it has a proper place. Now, context is a broad term here. It can cover why the work is needed, deadlines that affect it, existing code that it might impact, and business rules around the changes. Whatever it is, you as the author understand them much better than the reviewer does, because you've already been thinking about them. So it's your job to make sure that you've explained any context which is relevant to the PR. Now, in my experience, there are about 5 different groups of context, and these should be communicated in different ways. Number 1 is explaining why a piece of code is doing what it's doing. There are usually business requirements, these are usually business requirements or non-obvious technical requirements. So for example, if you have code that removes an email address from a log, it can be useful to have a comment to explain that this is because of GDPR reasons. This context is useful to have as comments or doc strings in the code, preferably next to the code itself. And the key here is that this is something that is useful for future developers to know about. So the code is a good place for this. The second type of context is context for the commits in the PR. Now, this is usually to explain the rationale for structuring the code in a certain way. So for example, I'm creating an empty function which will later be updated. Now, this is preferably with an explanation as to why you've decided to do things this way. This information isn't really useful for future developers. By the end of the PR, that function will have been filled in, and it's no longer relevant. So instead, this sort of context should live in the commit message. The third one is giving context for the whole PR. Now, this is usually explaining why the work is required, and it might point to a ticket, but it can also include details like deadlines or other related PRs. Now, this context should be added to the PR description, visible before any actual code changes, because they are useful for a reviewer to think about before even starting the review. Should a different team also review this? Should they prioritize this PR because it's extremely urgent? It also lets the reviewer know to keep in mind potentially other codes that the author maybe doesn't know as well or hasn't considered. Number 4 is asking for help. Now, if you've written code changes but you're not sure if it's the best solution, or you have questions about the code itself, comments on your own PR are an excellent choice. They can sit right next to the code, and they can handle multiple developers having a conversation about the best solution. Now, it's worth noting that sometimes the outcome of these discussions can lead to the first type of context, a comment in the code as to why something was ultimately implemented in that way. Number 5, explaining what the code is doing. Now, this is the type of context that well-written code probably shouldn't need, and definitely not as comments in the code itself. If you find yourself explaining what the code is doing in comments, rather than explaining why it's doing something, you can probably just improve the readability of the code instead. So this typically includes renaming things to be more accurate or descriptively named, and breaking large functions up into smaller, well-named sub-functions. Tip number 5, write perfect code first try. So why did I even bother with this talk? The idea here is that you can rewrite history to only show ideal final commits. Now, obviously, most of us aren't able to write perfect code first time round. However, we are all able to create PRs that look like we did by making sure that the commits show the perfect path to the completed PR. For example, if you create a variable name in one commit, then change it in the next, you might as well rewrite history so it looks like you named it perfectly in the first commit. looking at another example, let's say that you create some function that gets a foo, adds a default name to it, does some other stuff, and then returns foo. Now, if a reviewer spends a bunch of time explaining why setting the name to a literal string isn't a great idea, finds more documentation to help explain the problem, puts together an alternative solution for you, in this case, using a constant from a constants.py file, only to find that you've already done this in the very next commit, I can guarantee that they're not going to be super happy about this. You've just wasted 10 minutes of their precious finite time and mental energy for nothing. Even worse is if you decided that foo didn't even need to be named in the first place. Now, if this is how you coded it when you initially wrote the PR, by adding a default name and then deciding you didn't need it and deleting it later, that's fine. But by the time that you ask for a review from somebody else, it is worse than useless to show the intermediate stage. Please do not do this. Instead, merge the deletion back into the original commit that created the function to make it look like you created the function perfectly the first time around. Now, if there are sometimes genuine reasons for leaving a commit in an intermediate stage. For example, if you want to create and call a function, but the contents of that function are complex enough that you think they deserve their own commit, that's also fine. But please explain that in the commit message, or even as a comment in the commit, so that the reviewer knows what you're doing. Now, it's worth noting at this point that this particular tip, rewriting history, only applies to the branch that you're working on before asking for reviews. Once that a PR has been reviewed, or once that your PR might have been branched off of, there are valid reasons why rewriting history might be a bad idea. Mostly to do with changing code out from under somebody else's feet without warning. Tip number 6, review your own PR. Make sure that you find your own PR easy to read before asking others for review. Now, reviewing your own code before asking others to do it lets you practice all of the previous tips. By this point, you've hopefully made sure that your code does all of the right things and is tested. And so this is your chance to focus on making it a really well-structured PR without needing to worry about any further functional changes. Whilst doing this review, try to notice what you find easier or harder to review. Maybe one of the commits takes a lot more brain power for you to review. Maybe you had to reread a commit a couple of times to be able to review that one and be really comfortable with it. Whatever problems you have, your reviewers will likely face exactly the same issues, but much more strongly. Because at this point, they are not nearly as familiar with the code as you are. Take this chance to think if you can simplify the code so it's entirely easy to read. Now, sometimes you'll have commits that are just complex, or that feel like they're just complex, and splitting them up is, just makes them harder to keep all the relevant parts in mind, and you don't really see any way down. However, if you're not already used to doing this on a regular basis, I'm willing to bet that there are at least a couple of things that you can do to keep your PR view, to keep your commit simpler. On a more concrete note, you might spot a few obvious mistakes by doing your own review that will save you a round of comments and fix-ups. Finally, doing this last review, or doing this personal review, will help to build your ability to spot ways to make PRs easier to review. This is then something that you can pass on to your team to help them to craft better quality PRs, and ultimately, which will help to make your life easier as a reviewer for those PRs. So, what was the underlying approach here? I mentioned that all of these tips shared an underlying approach, and hopefully none of you are going to be surprised to find out what it is. Ta-da! Optimize for the reviewer. I can guarantee you that the easier a reviewer finds your PR to review, the better it will be for you as the author. there is one final topic which I wanted to touch on, which is more about optimizing the communication between you and your reviewer or reviewers. The human side, because your reviewer is also human, for now. Now, the last thing I want to talk about is the human communication that happens during the review. It's important to remember that the person reviewing your PR is, well, a person, but also that written communication is hard, especially when it's a discussion about your work and how it could be better. Now, this is a relatively nuanced issue which I don't think I can do justice to in the short time that I have left. So instead, I'm going to point you to an excellent article by Michael Lynch called How to Make Your Code Reviewer Fall in Love with You. It goes into a lot more detail about the pitfalls and ways to improve communications in a review, as well as a bunch of other tips on how to generally make your reviews better. Now, I'm also a firm believer that we should all aim to be better, kinder communicators in the workplace. Even tech companies are made up of humans, and it's those human connections that are the hardest to build, but I believe will give the biggest reward in the long term. So on that note, I'll also point you to Michael's other related articles, How to Do Code Reviews Like a Human, which, unsurprisingly, looks at how to communicate in a more human way when reviewing PRs. That's the end of my presentation. Thank you all for your time and attention.
All right, thank you, Ben. That was very enlightening. I have certainly caught myself doing some of the things you had not to do, so I'll learn that for next time. Right, so next up is we're opening up a round of questions now. The questions, so please don't just shout out loud your question. Wait until some of us from the organization takes the microphone up to you, because that way it will also be streamed and caught on camera as well, right? So the question should be in English. If you want to ask in Spanish, I guess that's fine as well. We can translate on the fly, but ideally in English. Right, so if you have a question, just raise your hand, okay? A bunch of them, okay. So I think the first one is sir over there. So let me bring the microphone up to you.
Hello, and thank you. Very, very interesting talk. Thanks.
Thank you.
Lots of insights. So, say I created a new branch and I did 8 commits, which are okay. Every of those commits follows good rules.
As long as they're small, yep.
Yeah, but I realized that the PR is a bit too big. Okay?
Sure.
So you said, do not apologize, just break it up. So how should I exactly proceed here?
So breaking up the commit is kind of mostly what tip number 1 kind of tries to find. If you...
Not the commit, but the PR is
the PR,
too,
yeah. So I think if you've already created a PR that is too big, you've not found the right components to pull out into their own PRs to start with. I would say what I would probably recommend doing at that point is trying to find the most logical point in the PR where you can just split the commits, right? If you can do it 4 commits in, great. If it's the one thing that I'll say is find somewhere that is safe to split. So for example, with the second tip, you can create all of the functions to add the kind of get your organization's secret key and get the auth keys and everything like that. All of that can get merged in and can sit in the code base completely safe because no one is doing anything with it. So that would be the advice. If you don't feel like you can do that in your PR, I would basically split the PR somewhere and make sure to add a bit of code that means that nobody can access what you've already merged. Feature flags are usually used for this, right? Like you can hide whole chunks of functionality behind feature flags, which means that until you turn that on, it's kind of dead code. So that would be my recommendation. And that, as long as you make it, you can even write in kind of the PR description, hey, this is what I've done. This was too big. I split it up between this one and this other PR. Like, just let the reviewer know that's what you're doing, and then the reviewer can also think about, hey, is this safe? Are these first 4 changes safe by themselves?
Yeah, thank you for the talk. I cannot pronounce your name, but thank you very much. My question is about if you think it's a good practice to have different kind of PRs, because everything what you're saying makes sense for me if you are making changes to production. But sometimes you are developing prototypes, and for example, in my company, we have PRs that demand high-level review or PRs that demand in-detail review, and the requirements are not the same. Do you think that makes sense?
Yeah, excellent question. So I think the amount of reviews is very dependent on the company and the team and also potentially the product, right? So, for example, a previous company I worked for did medical software. Some parts of that are much more sensitive than others. And so for those, ideally you want to get twice the number of reviews or reviews from the correct teams. This is something that we do at Kraken as well, where if you're making a change in a certain area, either it's important enough that you need a domain expert and a quality expert to approve it, to make sure that the important changes coming in are reviewed well enough. Prototypes is interesting because I'm not always convinced that prototypes should get merged into the code. But if that's how your company works, then yes, it absolutely makes sense to have different levels.
First of all, thank you very much for the talk. It was very helpful. I want to ask you if I am a reviewer of a PR and I notice that the design of the code must change, and it's a deep change. It's not like something you can do quickly. Should be done in the same PR, or should I do another issue with another PR with the deep change?
Excellent question. Again, it depends. So I would say it depends a bit on, again, the context. If the functionality needs to be merged right away because we need it today or this week, then I think there is value in kind of adding that as tech debt in a new ticket. Say, yes, this works and we need it today, but also we should absolutely spend some time later to fix it up in a separate commit. If you think that it's problematic enough that you want to stop the original code getting in, I think it's worth saying that in the review. Maybe you don't win that argument, but I think it's worth saying that. And at that point, I would argue if it's a deep structural change, it's probably easier for the author to just create a brand new PR altogether. There's absolutely nothing wrong with having a PR that never gets approved for various reasons and just closing that PR. That's certainly my take. Yeah, so hopefully that answered your question. Cool.
Thank you for this. I got super excited when you mentioned rewriting history as one of the tips. Then you said, but only do this before you have pushed it. And I got a little bit less excited. I wanted to ask, would you consider an extension to your tips that says it is okay to change history after only if there's a very strong agreement that this is done this way?
For sure. So as with all of these fantastic questions, it depends. And this one, I would say, depends on your company's Git branch, how your company wants to work or how your team wants to work. So the problems that you can have is, there are two main problems for me at least. One of them is that you've created your review. It's a relatively long review or it's a relatively complex review and somebody has left comments. You then go, great, I'll fix all of those comments and merge them back into the code. And at this point, the reviewer has to re-review the entire PR but have in a separate window open their comments to remember what it is that they've said to make sure that you've actually fixed those things in a way that they agree with. So for PR reviews, I would say that the gold standard would be to create fix-up commits at the end to show, hey, you've commented on this, I've changed this. This is how I've changed it. This is how I've responded to your comment. And then once because at that point, they only need to review those new fix-ups. It is much, much faster for them to do. Once they've reviewed and they've approved, at that point, you can kind of rebase everything and have everything be the perfect commit again. Sometimes, if the PRs are small enough, I actually prefer for people to merge them back in the first place. Because at that point, if it's a small change that takes me 5 minutes to review end to end anyway, I'll just redo the review with all of the right pieces in the right place. So it's very dependent. It can even be dependent to the individual PRs, I would say. The other problem that you have is that some companies, so at Kraken, we use trunk-based development. You pull from master, you do some work, it goes straight back into master. That's it. Other companies have kind of deployment branches or feature branches or whatever it is. And the problem with rewriting history there is that if you are rewriting history on a feature branch that other people are also working on, you can change the code out from underneath them, which means that when I go to bed on Monday night and wake up on Tuesday morning and do some work and try to merge my stuff, oh no, I now have to spend an extra half a day figuring out how to get my changes to work with the new code that you've put in, and yeah. So this is kind of, these are human communication things, right? If you agree with your team, hey, don't touch feature branches, but you can redo your own ones, or nobody touch this feature branch today because I'm going to mess around with it a whole bunch, or whatever it is, yes. So clear communication is the way around it. Obviously, this explanation took a little bit of time. I didn't want to add that as part of my 30 minutes. But yes, you're absolutely right. There's nuance to, it's not, you should never rebase after review. There are pitfalls, be careful. Cool.
All right, thank you everyone. That was the last question. We don't have time for more. Unfortunately, I will suggest if you still have questions, please find Ben around the conference and ask him directly. Please, once again, big applause for Ben Lomax. Thank you very much.
Thank you.